Let us see the first question, and the question is like this. We have three vectors given and we have to check whether it is in the span v1 and v2. So first and foremost we will write the augmented matrix. So the augmented matrix I am writing here with 0 7 0 6. All right, so what we have to do is we have to do the reduced row echelon. We have to get it to the reduced form, so apply the row operation. So first row 1 changes to row 2, we will change row 1 interchange, then we will apply row 2 changes to row 2 plus 5 times row 1, and row 4 changes to row 4 minus 3 times row 1. Okay, first and foremost we will interchange, and I'm writing it directly since I have the answer. So 0 minus 1 0, then 0 1 I'm subtracting here the row 2, and minus 2 4, and 0 minus 6 11, and 6. Okay, then we will apply the row operation for the row 3 and row 4. So row 3 changes to row 3 minus 2 times row 1, and row 4 changes to row 4 minus 6 times row 1. Then we will apply that, so it is 0 minus 1 0, 0 1 7, this becomes 0 6, and 0 0 17, and 0, sorry, it is 6, so make it 6 in the last row, that is R4 should be 6. All right, then we'll move to the row 3. We will apply row 3 changes to row 3 plus 6 times row 2. Then row 4 changes to row 4 minus 17 times row 2. Okay, now we will get 0 0 minus 1 0 0 1 7 0 0 42 0 0 minus 11 115. Now we will get the answer as so it is 0 x 1 x okay 0 x plus 0 y is equal to 42. So whatever, if you write the equation also, you will get the answer as the inconsistent form of equation, and you will have no solution, and that means the system B is not in the span, all right. So if it is inconsistent, it is definitely, it is not in span. So let's move on to the second problem. Let's show that the vector this belongs to the set 1 3 2 5. The first and foremost thing, we have to write the general form, that is c1 into c1 and c2 is equal to that. Okay, then what we have to do is let us write the augmented matrix, that is C matrix, that is 1 3 2 5 20 and 4. I think in span we have written about adding the two vectors, so that is what I've done in the first step. Now apply the row form. So row 2 changes to row 2 minus 3 times row 1, and the vector will be the matrix will be 1 2 0 minus 1, this will be 20 minus 56. All right, now I will apply row 2 changes to row 2 changes to minus times row 2. I'm just making it positive, so it is 1 2 0 1 20 56. Okay, now let me check for row 1. Let me change row 1 changes to row 1 minus 2 times row 2. So I will get the matrix as so 1 0 0 1, and minus 92, and 56. Now we are already in the reduced form, so we know that c1 is equal to 92, and c2 is equal to 56. Okay, in the first equation, the first general form, we know just reapply the c1 and c2 value. It is minus 92 1 2 plus so it is 56. So 56 into it is 2 and 5, and we should check whether it gives 20 and 4. So minus 92 and 276 plus it is 112 and 280. So if you do 192 minus 92, you will get 20, and if you do same for the 280 minus 276, you will get 4. So therefore I can say that 20 and 4 does belong to the span. Okay, let's move on to the third problem. The third problem is So we have to check, this is the third problem, whether this minus 1, 4, 11 belongs to the span. So first we will write the general form. So c1 into the first vector plus c2 into the second vector. It is minus 3, minus 5, 13, and c3 into the third vector. Minus 12 is equal to whether the checking part, the minus 1, 4, and 11. Okay, it is matrix. Now we will write the augmented matrix. C 1, 2, minus 4, minus 3, minus 5, 13, 2, minus 1, minus 12, given minus 1, 4, 11. Let us apply the row reduction. So the row transformation method. So row 2 changes to row 2 minus 2 times row 1, and row 3 changes to r3 plus 4 times r1. So the matrix you will get as 1, minus 3, 2, minus 1, and 0, 1, minus 5, 6, 0, 1, minus 4, 7. And again I will apply the row transformation. So row 3 changes to row 3 minus row 2. So you will get the answer as 1, minus 3, 2, minus 1, and 0, 1, minus 5, 6, 0, 0, 1, and 1. All right, we'll stop it here. So we already got a c3 as 1, c2 as 11, and c1 as 30. So please apply and check. So I directly apply to the first general form, 30 into the vector first vector, 11 into second vector, 13, and the 2 minus 1, the third one, into the third vector is equal to, we have to check 1, minus 1, 4, and 11. Now let me multiply. So it is 30, 60, minus 1, 120, and second vector will be minus 33, minus 55, 143, and 2, minus 1, and minus 12. So you have to check whether you're getting the answer as minus 1, 4, 11. If it is minus 1, 4, 11, then I can say that yes, the minus 1, 4, 11 belongs to span. So that is all about the span. Thank you so much.